Welcome back, everybody. Now that we have discussed motion graphs, position, velocity, and acceleration graphs, it's time to do a little practice. So let's look at, well, quickly, this is all our data that we've gone through, and in particular, we're going to do motion graph problems this time. Okay, so if you take a look at these three problems, these two, number 2 and 3, go together, so this question goes with this graph. All right, so what I'd like for you to do is to pause your video, work these three problems, and then I'll explain them. Okay, let's get started. So if we look at this particular problem, we got a lab cart that's rolling down, and we are having a motion detector give us the position and time graph. Okay, that's very important so that we know what kind of graph we're expected to get. Now let's take a look at the motion we're going to get. Up here, this object is on an incline, so it should be accelerating down the incline, and then once it gets here, the velocity should equal a constant, which means that the acceleration is 0. Okay, so what does that mean? So right here we have an acceleration. So we should have, for a position time graph, this should be parabolic motion right in here. So between here and here, this should be parabolic, and this should be linear. Let's see if we have one of those. All right, and hey, there's our answer right there. Okay, so we have a positive acceleration, parabolic motion here, and then we have a linear motion here, which the constant velocity between here and here. Excellent. Okay, so what will the rest of the graphs look like? So velocity versus time and acceleration versus time. So we're going to have this break point right here in each one, because we have two distinctly different types of motion between here and here. So the acceleration should be 0 out here and positive up here, so it should look something like that. And then the velocity graph should, since it's a positive acceleration, should have a positive slope, and I'm assuming it's starting at rest, so it should have a positive slope up to this point right here. And then after that, it should have a constant velocity, so it should look like this. Hey, that's this one down here. So this one is a distractor. This should have been the velocity time graph, right? But it was a position time graph. That's why it's incorrect. All right, and there we go. There's our answer, A. So let's take a look at our second two questions. So we have this graph. It's a velocity versus time graph. That's really important, okay? And then they give us a whole bunch of information here, but none of that information has much to do with these two questions. So a lot of it is just distractor information that we don't really need to worry about. So if we look down here, what are we looking for? Which of the following correctly ranks the displacement delta x of the three segments? Okay, so delta x, how do we get that from a velocity time graph? So if you remember, that would be the area of the graph. And that's the area of the velocity versus time graph, which is what we have. So if we go up here, we can highlight the different areas. So we have this section number 1 is this area here. We have a section number 2, which is this area between here and here. And then we have this section here, which is this area. All right, and if we go through and find this area, there are several ways you can do this. The easiest way might be just to count up the blocks, or you can visually see the difference. But if you find the area by doing geometry, 1/2 base times height, you'll find that the area of this one is 4 meters, because meters times second times time, seconds this way, is going to give you a unit of meters. This one turns out to be 5 meters, and this one here turns out to be 6 meters. So the answer is 3 is bigger displacement than 2, which is bigger displacement than 1. And so that's our answer right here. None of them have the same area. So you see an equal sign here, 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 and here. So all of these have to be wrong. All right, our last one. We are looking for which one correctly ranks the magnitude of the accelerations, A, for these 3 segments. Okay, so this is a velocity time graph. So the acceleration equals the slope. Now, a key thing, very, very key, is that it's asking for the magnitude of the acceleration. Remember, magnitude is like absolute value. So we don't care if it's positive or negative, just the size of the slope. So if we go back up here and look at the size of the slope, this one is a rise of 4 over a run of 2. So that's a slope of 2 meters per second, or meters per second squared. This one has a slope, a downward slope of 3 down and 2 over. So it's a negative 3 over 2 meters per second squared. But our question says magnitude, so we don't really care about that. We just care about the absolute value. And then our next segment is a rise of 4 over 2 again. So that's 2 meters per second squared. So these two segments are the same. And this one is a smaller magnitude, not because it's negative, but because it's 1.5 instead of 2. So let's see. This one looks like our answer, right? There you go. So those are the questions, or those are the answers to, sorry, let me show that to you again. So there's our answer. So those are our answers to our first 2. So we have one more question. It's this one right here. So I want you to pause your video. I want you to answer this question, and then I will go through it with you. All right, so let's take a look at it. And some of you will remember this one from class. I did this one in class with all of you. So this again is a velocity time graph. This is an acceleration time graph. So that means the slope of this graph should equal the values over here. So this is a negative slope, so that's a negative acceleration. This has 0 slope, so the acceleration is 0. This has a positive acceleration from here to here. And this has a 0 acceleration again. So let's see. Negative, 0, positive, 0. So it looks great, right? Well, there's one subtle problem. And the problem is that this negative slope here and this positive slope here are not the same magnitude. The positive slope is larger than the negative slope. So our error is that this one needs to be taller or this one needs to be smaller. This just needs to be a bigger magnitude than the one over here. Okay? And now the graph looks great. And that's it. You're geniuses. Those are our review problems, and you're doing great. So hang in there. The next thing we'll cover is review problems in general for all of kinematics. See you in a bit.